and we'll help you understand it step by step. You'll get to see model shapes like cubes, spheres, cones, and more to make tricky ideas simple. We'll also use amazing tools like PhET simulations to explore areas of plane shapes such as squares, rectangles, circles, and triangles. These interactive tools will help you see how shapes work and how to calculate their areas in real-world situations. This is a space where you can ask questions, try new things, and learn in a fun way. Are you ready to discover how awesome math can be? Let's get started.
You're welcome to Mathematics Clinic again. And I still remain your Mathematics Clinic teacher. Today, we want to look at the total surface area of a cuboid. You remember cuboid? Yes. You remember cuboid? Yes. They are called prism. And don't forget, we have a square prism. We have rectangular prism. All these are still cuboid. All these are still cuboid. Can you see this now? They are still cuboid. Now we want to look at the total surface. Can you see this now? All these are cuboid. Can you see this? Now we want to look at the total surface area of a cuboid. In looking at the total surface areas of a cuboid, the easiest way is for you to unfold the cuboid. When you unfold the cuboid to give you net of a cuboid, it is easy for you to get the total surface areas of that cuboid. Let's go into this now. Let's try and see how we can unfold a cuboid into net of a cuboid. This is a cuboid that has 6 faces. And each face on it look like a rectangle. Now, when you come here now into the net of a cuboid, of course, like I said, it has 6 faces. Let me count if it's going to be up to 6. 1. Okay, let me use this to count for you so that you don't get lost. 1, 2, 3, 4, 5, 6. So that means each face on it look like a rectangle. That shows we are going to have 6 rectangles on a cuboid. And we want to find the total surface areas of that cuboid. The first thing to do is that this is a 3-dimensional shape that has length, breadth, and height. Now let's look at it now. When you look at the first shape here, this is the length of that shape. And this is the breadth of what? Of the shape. And of course, when you look at this side, I'm going to start this with this red. Is the same thing as this side. That is 1 and 5 is the same thing. This place is also length. And of course, this place will also be what? Breadth. So let me bring that one out here. For this to be what? To be length and what? And breadth. Now let me pick the second side with another letter, which is the one inside here. So this is the length and this is the what? The height, which is also means this place and this place is the same thing as length and what? And height. So I can also bring that one here as what? Length and what? And height. This is my length and this is my what? Height. Let's see the third part, which is 4 and 2. 4 and 2. They look alike. Yes. So this is breadth and this is what? Height. This is the breadth. And of course, when you raise this up, you see that it will be of the same size with this. And that is why it is what? Breadth and what? And height. So this is the breadth and what? And height. So that means in a cuboid, we are going to have 2 lengths breadth, 2 lengths height, 2 breadth height. I will repeat. Look at it. Length breadth, which is 2. Length height, which is green. Then breadth height, which is what? Blue. Can you see that now? So what do you want to do to this? We want to look at the total surface areas of this. So how do you get the total surface areas of this now? Can we come back here now and say total surface area? The total surface area of a what? Of a cuboid now is going to give me, what is this first one? That will be, don't forget, it's going to be 2, 1 and 2, which is, this one now is 1 and 5. That is phase 1 and phase what? Phase 5. So which is going to be 2, which is going to be what? 2 into what? Length and what? And breadth. Can you see that? Because it's going to give me 2, 1 and what? And 5. Okay, let me keep that. Let me move on to the second one, plus the second one, 2, length and height. That is length and what? And height. Don't forget that the areas of a rectangle is length multiplied by breadth. But because this one is length and height, you multiply that together. So let's move on, which is what? This one now is, look at this, that is 3 and what? And 6. That is the phase 3 and phase what? 6. Now let's move to the last one, which is what? Breadth and height. Breadth and height, which is phase 2 and phase what? Phase 4. Phase 2 and phase what? Phase 4. That's plus 2 into breadth and what? And height. So can we bring everything together? Of course, everything all together will become 2 length breadth plus 2 length height plus 2 breadth height. Of course, something is common to the 3 of them. Great. 2 is common to them. So we can say since 2 is common to them, then that can be 2 into length times breadth plus length times height plus breadth times what? Times height. This is the total surface area of a what? Of a cuboid. The total surface areas of a cuboid is 2 into length times breadth plus length times height plus breadth times height. It's as simple as that. So can we take an example now? Can we take an example? Let us take an example that we have a length. Let's take an example. If you have length of a cuboid is 10 centimeter. The breadth of that cuboid is 8 centimeter. And the height of the cuboid is 5 centimeter. What is the total surface area? We can use this. You can use this. We can also use the formula. If I'm going to use this now, I'm going to clean this cleanly. Can you see that now? And I'll come back and use the formula if you are going to get the same thing. So the length is what? That is 10 multiplied by what? 8. So that is 10 multiplied by 8. And that will give me 80. That will give me 80 centimeter square. Okay, let me come here and clean this gently. Length and height. Length and height. So that is 10 multiplied by 5. And that will give us 50 centimeter square. So the last one, which is what? Breadth and height. Breadth and height. That is 8 multiplied by 5. And that will give me 40 centimeter. So centimeter square. Can I add the 3 together? Don't forget they are all 2. So 2 of these. 2 of these. That will be 160 centimeter square. 2 of these. 100 centimeter square. 2 of these, 80 centimeter square. I want to be sure if you are seeing my board. Oh no. Okay, I think you can see my board now. Great. So you can see that now. So that means I have 160 plus 100 plus 80. So what is that going to give us? So can we add all that together? 160 plus this, that'll be 260. Is that not? Plus 80. 260 plus 80. When you add this is 4. That'll be 300 and what? 40 centimeter square. Let's check that. Can we see that? Yes, I just want to be sure you can see that. So can we use the formula to cross-check if what we are doing is correct? 2 into length times breadth. It's just like the same thing. 2 into this. Length multiplied by breadth, that is 80 centimeters square plus 1, that is what? 50 centimeters square plus 40 centimeter square. So can we add it together? 50 plus this. Great. That'll be 2 into this plus this, that is 90. That'll give us 170 centimeter square. So can we multiply that together by 2? 2 multiplied by 0, 0. 2 multiplied by this, that is 14. 2 multiplied by 1, 2 plus that one, that is 340 centimeter square. Can you see it's the same thing? Can you see it's the same? Yes. So you can use the formula. You can also use this arrangement to find the total surface area of a what? Of a cuboid. Now, the last thing we want to find now is looking at the volume, which I'm going to manage this place, the volume of a cuboid. Volume of a cuboid. I'm going to use this. The formula for volume of a cuboid is length times breadth times height. So what is our length? 10 centimeter multiplied by our breadth, 8 centimeter multiplied by our height, 5 centimeter. Let me see if you can see that clearly. Let me check if you can see that clearly. Oh no. Oh no. So I'm going to use this place to find the volume for you so that this can be clear. So I'm going to clean here now. Okay. So we were looking at the volume. So the volume will be equals length multiplied by breadth multiplied by height. So that will be the length is what? 10 centimeter multiplied by breadth, 8 centimeter multiplied by 5 centimeter. So what is that going to give us? Can we do that quickly? I want people joining me to do that. Those that are in the math clinic, can you do that? That is 80 multiplied by 5. Great. So that will give us what? This multiplied by this, that is 80. That will give us 400 centimeter cube. Don't forget the unit of a volume is what? Is cube. So 400 centimeter cube. So that is how far we can go on cuboid. I'm going to give you this as an assignment, and I want you to drop the answer in the comment section. Number 1, if the length of a cuboid is 15 centimeter, the breadth is 10 centimeter, and the height is 8 centimeter. What is the total surface areas of that cuboid? And what is the volume of that cuboid? Number 2, the length is equals 16 centimeter, the breadth is equals 12 centimeter, and the height is equals 10 centimeter. So find the answer to these two and drop your answer in the comment section. So far, so good in the math clinic. So far, so good. So far, so good. So far, so good. So far, so good. Is that the total surface area of a cuboid is what? Is 2 into length times breadth plus length times height plus breadth times height. And the volumes of a cuboid is what? Length multiplied by breadth multiplied by height. That is how far we can go in the mathematics clinic, where we are looking at total surface areas of a cuboid. If you are joining us for the first time, try and like this video, share this video with others, and make sure you subscribe to this channel. See you next in our mathematics clinic class. Bye.